Hey everybody, how's it going? Jake here, coming at you with another math lesson today, doing it live again. Happy Monday. Hope everybody's week is off to a good start. But today we're going to be going over just kind of the easiest way that you can apply quotient rule to find the derivative of a function. Last week we went over product rule. This week I want to go ahead and get into quotient rule. But I'm just going to be showing you the quotient rule formula and the shortcut that you can use to easily apply this formula to any quotient rule example to find the derivative of a function. So by the end of this video, should hopefully make quotient rule a little bit easier for you, so you can go off and start applying that on your own. One thing I want to point out real quick before jumping into the problems that I have for you today: quotient rule is one of the topics covered on my free Calculus 1 study guide. It's also covered in my complete Calculus 1 package. The links to both of those things are in the description down below, so go check those out. I think you'll find those both very helpful. So anyway, without further ado, let's go ahead and jump into the examples. As always with these live streams, though, if you do have any questions along the way, throw them in the live chat and I'll do my best to help answer whatever questions you have. Even if they're not related to quotient rule, I'm happy to give a shot to whatever questions you have. Can't necessarily guarantee that I can answer any question live without getting a chance to look into it, but I'll do my best. Maybe I'll even make a video about it if I can't answer it on the spot. All right. So first thing we're going to do here, we're going to find the derivative of this function here, y equals e to the x over 1 plus x. So really, when you're looking at a question like this, where you're trying to find the derivative and then you have some function that is just a fraction. So in this case, it's pretty clear. We have our entire function is just one big fraction, right? We just have this numerator here and this denominator here. There's no other stuff within our function. So that makes it pretty, easy to see that this is a great example of, an opportunity to apply the quotient rule. So first of all, where you probably want to start, or what you want to ask yourself, is what is the quotient rule formula? Well, the quotient rule formula can be a little bit hard to remember, but I do have a trick that you can use that will make it a little bit easier to remember, so that if you don't have the formula in front of you, you'll be okay to answer a question like this. But let's just go ahead and start with the formula first of all, and then I'll kind of talk about how you can remember it. So first of all, if we're taking the derivative of some fraction function like f of x over g of x, basically this is just going to be given by this formula here. All right. So like I said, there is a way to remember this that makes it a lot easier to keep in your mind, basically. So there's kind of just a little bit of like a little song or tune that you can remember that helps you remember this, which is basically you're going to take the derivative, and this is not the song, sorry, I'll get into that in just a second. But just to kind of explain the formula, we're just going to take the bottom of our fraction times the derivative of the top of our fraction minus the top of our fraction times the derivative of the bottom. So notice this numerator here is really kind of similar to the product rule formula, except with product rule, this was a plus sign, whereas in the quotient rule, it's a minus sign. So the very important thing that does is it actually matters if we do g times f prime first versus f times g prime first. In product rule, and I talked about this in my video last week, we could kind of switch these up, because g times f prime plus f times g prime is the same as switching those and doing f times g prime plus g times f prime. But with quotient rule, it's very important that you get the order right, because of this minus sign right here. So since we're doing this minus this, if we switch the order, then this is going to be the term that gets the minus sign, and this term is going to be positive. So basically, you're going to end up with the negative version of what your derivative should be. So you do want to be very careful to put the order correctly here. Then you're going to have all of that over the bottom of your fraction squared. So how do you remember this? Well, keep in mind, basically, instead of thinking of this as f and g, because that can be hard to keep straight, think of it as the derivative of like a high and a low. So just think of this as like, the top of your fraction is high, the bottom of your fraction is low. So it's just high and low. It's pretty easy to remember. The way you remember it is it's going to be low d high, so low d high minus high d low all over low squared. So this is basically just saying the bottom times the derivative of the top minus the top times the derivative of the bottom. So low d high minus high d low just has kind of a nice little jingle or a nice ring to it. Low d high minus high d low all over low squared. So that's really all there is to it. This is a good way to remember it. And like I said, both of these are on my Calculus 1 study guide. It is completely free. There's a link down in the description below if you want to go check that out. And I do go over quotient rule in quite a bit of detail as well in my complete Calculus 1 package. Link to that is also in the description. But let's go ahead and actually get into how to actually apply this. So first thing you want to do when you're finding the derivative with the quotient rule, I think it helps to really lay out what is your f and your g, or similarly lay out what is the high and the low. So the high is, in this case, e to the x. It's just the top of our fraction. Whatever's on the numerator is what your high is. Whatever's on the denominator is what your low is. So in this case, 1 plus x. Okay. Once you've laid out your high and your low, then you need to find the derivative of each of these. So d high is just the derivative of your high, and then d low is just the derivative of your low. Well, the derivative of e to the x in this case is just e to the x, right? It's a very unique function where its derivative is itself. Derivative of e to the x is e to the x. The derivative of 1 plus x, we can kind of think of each of these, the 1 and the x, separately. 1 is a constant, so the derivative of 1 is 0. And then x, the derivative of x with respect to x is 1. So the d low in this case is just going to be 1. So once you've figured out your high, your low, your d high, your d low, then you can just apply this formula. So we're going to get low d high. So low is 1 plus x. Let's go ahead and scroll down a little bit here, actually. So low d high, low is 1 plus x. And do be careful when you're plugging these 4 pieces into this formula here. Make sure to put parentheses around them, because otherwise things aren't going to distribute and you're going to end up with potentially the wrong answer. So low d high, we got our low, we need our d high. So d high is e to the x minus high d low, so e to the x times 1 all over low squared. So all over 1 plus x squared. And again, keep in mind, you should put parentheses around that. It might even help you if you just write parentheses around these 4 things right off the bat, so that you make sure you're squaring the whole 1 plus x and not just applying the squared to part of it. Okay, so this is our y prime. This is the derivative of this function. So now what we can do from here is simplify this. So first of all, e to the x will be able to distribute. So we're going to get y prime equals e to the x times 1 is just e to the x. E to the x times x is plus x e to the x. And then e to the x times 1 is just e to the x. So then we're going to get minus e to the x. And then all over 1 plus x squared. We could definitely distribute that out if we wanted to. So do keep in mind, if we wanted to do that, 1 plus x squared is the same as, 1 plus x squared is the same as 1 plus x times 1 plus x. The squared does not just distribute into the parentheses. We do need to FOIL this out. So doing that is going to give us, on our denominator, 1 times 1 is 1. 1 times x is x. X times 1 is x. And x times x is x squared. On our numerator, we have an e to the x and a minus e to the x. Those are going to cancel, and we're just going to have x times e to the x on the numerator. And then we can combine our x's down here. So we just get x e to the x over x squared plus 2x plus 1. And that's going to be the final answer for the derivative of our function. All right, I'm not seeing any questions in the chat. Let's go ahead and go on to the second example here. All right. So our second example, we're going to differentiate h of t equals 2t over 4 plus t squared. So I did go obviously into quite a bit of detail in the last example. I'm going to go through this one a little bit quicker. I will go ahead and just jot down the formula, or at least the kind of shortcut formula that I like to use. So remember how you can remember it: the derivative of x or t. In this case, we're taking the derivative with respect to t of the high part of our fraction over the low part of our fraction. Obviously, I've shortened it to 2 letters, but think of it like high and low, is low d high, so low d high minus high d low all over low squared. Okay? Low d high minus high d low all over low squared. So again, next thing we want to do is write out, first of all, the high and the low. So the high is always just the top of your fraction. We know we have just one big fraction here that we're taking the derivative of, so clearly quotient rule is going to be applicable. The high is just going to be the top of your fraction, so 2t. The low is just the bottom of your fraction, 4 plus t squared. Okay? Then you want to find the derivative of the high, the derivative of the low. D high and D low just mean derivative high, derivative low. So D high, the derivative of 2t with respect to t, is going to be just 2. The derivative of 4 plus t squared can be done using the power rule. So the derivative of a constant is 0, but the derivative of t squared, you would bring the t down in front, keep your t as your base, and then lower the power by 1, or subtract 1 from the power. 2 minus 1 is 1, so 2t to the 1 is just 2t. Okay, then we can use this formula. Low d high, so low. And again, make sure you want to put parentheses around these. You don't want to forget that, because when you start plugging this into the formula, if you don't have your parentheses properly applied and you don't distribute terms, across these different terms, you're going to end up with the wrong derivative. So low d high gives us 4 plus t squared in parentheses times d high times 2 minus high d low, so minus 2t times 2t, all over low squared. So all over 4 plus t squared squared. Okay, so this is h prime of t now, because we started with h of t. Okay, so now we can go ahead and simplify this. So the 2 is going to distribute into the parentheses there, giving us 8. 4 times 2 is 8, plus 2t squared. 2t times 2t is going to give us minus 4t squared. And then that's going to be all over. Remember, when you have something in parentheses like this, all squared, you do not just square each of these terms. You have to be very careful about that. Squared like this, when you have things being added or subtracted, does not just distribute into the parentheses like that. We need to instead write it as 4 plus t squared, 4 plus t squared. And then what we're going to have to do is FOIL this out. So then we're going to have the first times the first, the outer terms multiplied, the inner terms multiplied, and then the last terms multiplied. So then we can simplify this. First of all, 2t squared minus 4t squared, that's just going to simplify to negative 2t squared. And then we have a plus 8. And then on the bottom, we're going to get 4 times 4 is 16. 4 times t squared is 4t squared. t squared times 4 is another 4t squared. And then t squared times t squared gives us t to the 4th. Then we could simplify this a bit further by combining these t squared terms here on the denominator. So we're going to get minus 2t squared plus 8 on the numerator. And on the denominator, t to the 4th plus 8t squared plus 16. And that's going to be h prime of t. And that's it. Just a, quick application of this low d high minus high d low all over low squared. And again, you do want to be very careful. The order of this numerator does matter. It's not like product rule where you can kind of switch the order around a bit to make it more convenient. All right. Still not seeing any questions in the chat, so we'll go ahead and jump on to the third example here. If you do have any questions, feel free to throw them in the live chat, and I'll be happy to help answer them for you. All right. So now we're going to, again, use the quotient rule to find the derivative of this function here, where our function is y equals x plus 1 all over x cubed plus x minus 2. So again, let's go ahead and start out with the quotient rule formula. So the derivative with respect to x of high over low, the high part of our fraction and the low part of our fraction, is low d high minus high d low all over low squared. So then again, we're going to write out, let's go with this color. That's a good color. We're going to write out the high part of our fraction, which is just the top of our fraction, x plus 1. The low part of our fraction, which is just the bottom, the low part, x cubed plus x minus 2. And then again, we write out our d high and our d low. And like I said, this is one of the topics covered on my free Calculus 1 study guide and my complete Calculus 1 package. If you want to grab those or check those out, learn more about them, whatever you want, there is a link down in the description below. Highly recommend checking those out. They are very helpful. Gotten lots of positive feedback on those and people getting some really good use out of them. So highly recommend checking those out for yourself. But then for this, we will take the derivative. The d high is just the derivative of high. So the derivative of x plus 1. The derivative of x is just 1. The derivative of a constant plus 1 is 0. So that won't do anything. Then for this, we're going to use power rule. So we bring our 3 down in front, leave our x as x, minus 1 from the power, bringing it down to 2. The derivative of x is just 1. And then the derivative of a constant minus 2 is 0. So that won't do anything. Then again, we apply this formula. So low d high, low. And again, let's go ahead and put these in parentheses. It does really help to kind of keep things straight. Just put all 4 of these. As soon as you figure out your high, low, your d high, your d low, just completely surround them with parentheses. Because now what we're going to do is we're going to do low d high. So this whole low, so x cubed plus x minus 2 in parentheses times d high, so times 1. Then minus high d low, so minus x plus 1 in parentheses times d low, 3x squared plus 1, all over low squared. So all over this whole thing squared. Okay, and this is what y prime is going to be. Okay, so now we can go ahead and simplify this. So we will x cubed plus x minus 2 all times 1 is just the same thing, x cubed plus x minus 2. This is going to have to be FOILed. So we're going to do the first term times the first term. And this is another thing to be very careful of when it comes to distributing and all that in parentheses. We need to keep a minus sign here, and then we're going to go ahead and keep parentheses around this foiling, because the negative sign is going to have to be distributed to all this stuff here when we're done. So first of all, x times 3x squared gives us 3x cubed. X times 1 gives us plus x. 1 times 3x squared gives us 3x squared. And then 1 times 1 gives us plus 1. On our denominator, again, you want to be very careful. When you have a bunch of terms being added or subtracted together within parentheses like this, and it's all squared, the squared does not just simply distribute into these terms. What we need to do is write out x cubed plus x minus 2 times x cubed plus x minus 2. Because remember, something squared just means that thing times itself. We need to times this whole thing by itself. Okay? So then we can go ahead and we would be able to combine our like terms within these parentheses here at this point. In this case, there are no like terms. So we can just go ahead and distribute the negative sign to all 4 of these terms now. So we're going to get x cubed plus x minus 2 from out here, minus 3x cubed, minus x, minus 3x squared, minus 1. And then on our denominator, this gets a little bit kind of complicated to keep track of. We're going to do basically the first term times each of these 3, then the second term times each of these 3, then the third term times each of these 3. So I'm going to go ahead and do kind of multiple colors here so we can keep track of this. So first we're going to do this first term here times each of these 3 terms. So x cubed times x cubed gives us, when you multiply 2 things with the same base, you add the power. So that gives us x to the 6th. X cubed times x gives us plus x to the 4th. And then x cubed times negative 2 gives us minus 2x cubed. Okay. Then we're going to go ahead and do this second term plus x times each of these 3. So x times x cubed gives us plus x to the 4th. X cubed times x is plus x squared. X times negative 2 is minus 2x. And then get a third color here. Let's go with orange, is a bit different. We'll have the minus 2 now being multiplied by each of these 3 terms. So minus 2 times x cubed is minus 2x cubed. Minus 2 times x is minus 2x. And minus 2 times minus 2 is plus 4. All right. So now let's go ahead and we will combine our like terms on the numerator. So we have an x cubed and a minus 3x cubed here. So that gives us minus 2x cubed. We have a minus 3x squared. Then we have a plus x and a minus x. So those are going to cancel. And then we have a minus 2 and a minus 1. So that gives us minus 3. So the x cubed minus 3x cubed, counted for those. The minus 2, the minus 1, and the minus 3x squared. Okay, so I accounted for all those down here. Okay, so then again, we can combine our like terms on the denominator at this point. So there's only one x to the 6th here. Then we have x to the 4th. So that's accounted for. X to the 4th plus x to the 4th gives us plus 2 x to the 4th. Minus 2x cubed minus 2x cubed. So that's minus 4x cubed. Plus x squared, and that's the only x squared term. Minus 2x gives us minus 4x, and plus 4. It's quite a doozy. And then, yeah, there's no more like terms, no more distributing. There's no really anything else to do there. So that should be it for that. And that is just a simple application of the quotient rule here. Like I said, this is one of the topics on my free Calculus 1 study guide and my complete Calculus 1 package. Links to both of those things are down in the description. go check that out. And if you did get some value out of this video and you feel like this really helped with Quotient Rule, please do me a huge favor. Go ahead and hit that like button. It really helps to get this video out to more people so we can keep growing the Jake's Math Lessons community and so I can keep making more videos like this. Well, anyway, don't see any questions, so we'll go ahead and wrap things up there. Go ahead and hit that subscribe button as well and that bell icon so you're notified when I go live each week, and hope to see you live next Monday night. Thanks, and see you next time.